Hi, I'm Mrs. Webster, and today I will be performing a science experiment for you related to changes in states of matter. By the end of our experiment, we will be able to answer the question, in what ways do we purposefully change the states of matter? Now, before we start our experiment, we have to make sure that we're ready to work in the lab and practice lab safety precautions. I have my goggles to protect my eyes. I have my lab coat to protect my clothing from any spills. And I also have my hair in a ponytail to keep it away from any flames or any other debris or substances that can harm my body in any way. I would like you to take some time out to look at your body and the person next to you to determine if they're ready to start science experimenting. Okay, I see that we're ready now. Let's look at what supplies we need to perform today's experiment. I have here a hot plate with a skillet, vegetable oil, oven mittens, matches, a candle in a candle holder, and grade A eggs. As you can see, or make an inference that I might be cooking today. Now, how is cooking related to changes in states of matter? You may wonder. But I'm going to demonstrate for you how this applies to your life and science. First, we're going to take a candle. Now, you cannot do this at home without parental consent. Even with parental consent, I wouldn't advise you to do it. Okay, I'm going to take a match out of this matchbox and I'm going to strike it. Not too close to my body, okay, but far enough that keeps me out of harm's way. We're going to light this candle. And while I'm lighting this candle, I want you to think about what changes might occur as this candle is lit. Okay, now it might take some time. It might take some time. So while this candle is performing science or going through changes in states of matter, we're going to go over here to our hot plate and we're going to talk about hot plate safety. Hot plate safety is very, very important. Okay? It can cause burns when not used properly. So, first thing to look at is to make sure your cord doesn't have any frays or any flaws. Make sure it's plugged in where no one can trip. I will be the only one coming in this area, and I'm going to make sure that I watch where I'm stepping. Also, I have oven mittens because when the plate becomes hot, it would also heat up my skillet. And I want to make sure that it is secure and that I am safe. I'm going to turn it on to a setting of low to medium. Not high. High is very, very extreme. It can get up to 540 degrees if I turn it up to high. Okay? So I'm going to lay this here and let's check back with our candle. See if any change has taken place. Our candle started off as a solid. Okay? And remember, solids have a definite shape, definite volume, and their molecules or particles are all compact together. And we're looking at a physical change that can take place between this candle while it's lit. So take some time to talk with your partner about what do you think will happen as this candle continues to burn. Turn and talk with your partner and make a prediction or a hypothesis of what you feel would take place as this candle is lit. All right, let's zoom in on our candle one more time. Wow, I see some liquid. Wow, there's liquid now. Is our solid changing into a liquid? Amazing. We're going to give it a little more time. Now we're going to move over here. Okay. Our skillet should be warming up. Okay. Give it a little time to warm up a little more. Alrighty. Now,
I smell it.
I smell it now. Okay. So let me get my supplies together. An egg. Now I won't be making any omelets. Okay, we're experimenting. An egg is hard on the outside, but on the inside there's soft liquid that takes the shape of its container. Our eggshell is hard and round, oval shape. Therefore, the liquid inside must take upon the shape of this egg, which is oval as well. But once I crack it into the skillet, it's going to take the shape of my skillet, which is round and circular. Okay? Now I'm going to lay my head here to protect it from falling over. And I'm going to spray my pan with some vegetable oil. Keeps it from sticking. Non-stick vegetable cooking spray. Okay? And all I need is a tad. Okay? I don't want to spray too much. Okay, now I'm just going to crack it on the side. Make sure eggshells do not fall in. All right, what do you think is going to happen as this egg heats up or cooks in this heated skillet? Keep it there. Okay, we're going to take some time to let that cook a little to see what happens. I can smell it. Wow. Wow. I see some of the egg has turned white. A liquid that was clear is now turning white as it cooks in a hot skillet. Wow, and this is a chemical change that's taken place. Wow, I wonder why a cooking egg is a chemical change while a lighted candle is a physical change. How about if you all take some time to think about and discuss with your partner how these two are different? Although they are changes, how are they different? What makes the candle a physical change while the egg is a chemical change? Wow, look at that egg. It is really cooking. Now I'm just going to take my oven mitt here, okay, to make sure the egg is cooking thoroughly all over. I would love to have some bacon right now. Bacon and eggs. Wow. Now since my egg is hardening, I could go ahead and turn my hot plate off so it can cool down in the process. Because if you didn't know, eggs continue to cook in a heated skillet even after the heat has been turned down. And I know that from cooking. Amazing.
It's beautiful.
So what we're going to do now is discuss the changes. We have the chemical changing of an egg and the physical change of a lighted candle. Go into the candle. Look at the candle. Wow. Liquid. Wow. Now what I'm going to do is pick the candle up. Something that you should not try, just so you can see the liquid. Wow. Okay. Now I'm going to go ahead and blow my candle out because we have a change in the state of matter that has taken place. Okay. So let's look at the two differences between these types of changes. Okay. I'm going to use my board here to compare a physical change to a chemical change. What makes them different? Physical change. What happened? We started off with a solid that changed into a liquid. In our chemical change, we had a liquid that changed into a solid. The difference is, as my candle is cooling, it's turning back into its original state. Wow, that's what makes it a physical change. It was once solid, then liquid, now it's back to solid again. Amazing. So, the composition of my candle didn't change at all. It can turn back into its original state with no change in its composition at all. That's what makes it a physical change. It goes from a solid to a liquid, then back to a solid. But what made it change from a solid to a liquid? What did I have to do? I had to light my candle. And when I lit my candle with a match, I applied heat. That's what made it change. And I'm going to write that in red for you. Heat is what took place. Okay? Look at our chemical change now. Liquid to a solid. What did I apply to this liquid for it to turn into a solid? Heat again. I applied heat to both of them. Heat, the fire, the temperature rises. However, after my egg cools down, will it turn back into a liquid? Think about that for a minute. When you have breakfast in the morning and your mom scrambles you some eggs, or maybe you like them over easy or sunny side up, when your mom puts them on their plate, do they turn back into a liquid? Think about that for a minute. When you go to a breakfast buffet or go have brunch, when your eggs are brought to you, are they back in their original state they were in when they were in that eggshell? No. That's what makes it a chemical change. A liquid turns into a solid, but it cannot go back to its original state. That's what makes it a chemical change. The chemical makeup of it cannot be changed back. It's just impossible. That's what makes it a chemical change. Now, you're going to take some time to find out other ways you purposefully change the states of matter. Okay? As my lesson ends, your teacher will hand out you some more supplies, and you will experiment on your own with some solids and liquids. And I hope that you take this lesson and relate it to the real world and how science is all around you. You are even made up of science. So scientists, happy experimenting.